So, good evening. This is our final project for Big Data for Business. I am Bridget Thomas, and my teammates are.
I'm Satvik, Venkatesai Satvik Reddy Tanamuddi.
And I'm Ganesh Taluri.
Yeah, so we worked on this project where we created a pipeline, and we are doing our EDA transformation and applying machine learning on a credit card churning data set which we got from Kaggle. So the main objective or the main question for this problem is that a bank is facing a lot of churning, especially credit card users are churning a lot, and our aim is to predict those churning customers using our machine learning models, and uh, we are creating this pipeline. So let me go through this the tools we have used here. So we have used Azure. In Azure, we have used Azure Data Lake Storage, and we have used Azure Data Factory to create the pipeline to have a flow of the flow of this project. So let me and we are using Azure Databricks for transformation and running Spark. So let me explain the workflow. Let me start by debugging this pipeline because it will take some time to run. So I click when I click debug, the pipeline will start running. So if you see at the bottom in the progress bar, it should come up. Yeah. So the first object, which is copy data set, is being running right now, or is it queued right now? It will start running. So it's succeeded. So what happens is I have this data set stored in my repository, which is shared. So we are getting this CSV file using this copy data set, and we are storing it in my Azure Data Lake storage, which provides like a staging area. So we have the data here in the raw data, and the data is being saved here, and then we switch over to EDA, where we are doing exploratory data analysis, and you see it's in progress right now. But to understand more about it, Ganesh will speak on it.
Yeah. Coming to the EDA, our dataset consists of 23 columns, where it consists of both categorical and numerical columns. Uh, our main dependent variable is attribution flag, where we need to find whether the customer will return to the bank, or are they leaving based on the model that we predict. Coming to the columns, we can see that Selenium, it's like an ID, and the remaining existing attrition flag is our dependent variable, and all the remaining columns numerical variable customer age, gender, income, and everything. And also we can see all the other categorical and numerical columns here, where based on that other columns we predict. And here we are using like a handy spark, which is similar to like pandas, but here instead of running in a single node, it runs as a distributed form using the handy spark. It's like a extension to the spark. And we are getting the data from as you can see that from the data like from the first stage, and come and copying to the second stage called EDA. And in the EDA we are using this mount, and we are getting the data. After the getting the data, uh, after getting the data, we are seeing what are the numerical values, and just describing, seeing everything, what the mean and the summary of each. Here we can see we have total 10,000 rows in the data frame, and we can see all the mean median for that. Just we have written a code for to calculate only for numerical columns rather than the whole data set. Coming to the spark, we can see like we are finding if you have any missing values, and we wrote a code there, so we don't find any missing values. And also other, coming to the categorical analysis, category column analysis, we gone through. We have used like a handy spark plots rather than going to a pandas, uh, matplotlib or Seaborn, because it runs on as a distributor. So we use this handy spark. So we draw histogram for this categorical variables. We can see the blue category users use blue category are high, and as low as platinum. And coming to the other category, you can see attrition rate. Here there is an imbalance in the data frame. We can see the dependent variable is something like it's like a 16% than the existing. So there may be some negative impact. Like we have to adjust this imbalance. So we have done the imbalance techniques like smart to balance the data and see if there is unbalance, and we have done that. And after that we can see different categorical plots. We can see the how the education level, if the education level affects the prediction. And we have done all the income category, and everything. And for the categorical variables, for the numerical, coming to the numerical variables, we have like a normalized. So here what we have done is like for the numerical variables, we have distributed the column like as a normalized distribution. We wrote a we wrote a function called analyze. So first, we can say it's a challenge here where we have written a code so that we using RDD, it runs as a distributed, like it creates histograms, everything using RDD. Uh, Regine, can you move up? So can see the code. Um, you can see the function we have written here. So where it calculates all the mean, median, and the is a distributed way using a handy spark and the RDD, and it collects the data into histograms in the RDD, and we plot it as a using plotly. So where uh, we run all the calculations, everything in the RDD, and we're just plotting in the uh, as a as a plots in the must know. And we can see the plots here, like how the credit card limit is skewed towards right, and there is and also we can see all the other plots and utilization, how the credit card utilized. We also see how the normalized the data, and we can see how other different dependent variables how depends for the uh, prediction of models. From now on, my friend Satvik.
So coming to the transformation part, like we have checked that data types are correct as desired. So also we have dropped some unnecessary columns which contains a lot of text and some the IDs. And we have checked the correlation between the independent variables and the dependent variables. So we have converted the categorical. Uh, can you go down? Yeah, we have converted the categorical columns into ordinal values using string indexer, and we have converted the ordinal values into zeros and ones using one hot encoding. And we used vector assembler to create an unscaled feature column for the model. And we scale the features model using standard scaler. And we created a pipeline to transform the entire data set, splitted the data set into train and test, and used a smart analysis like sample minority oversampling technique on the train data set. And we saved the we transformed train and test data into the ADLS Zen to Azure storage. The ML part will be explained by Regine.
Yeah, so as you can see, the pipeline has already been completed successfully, but I will come back to this after explaining the machine learning part. So, in the machine learning section, what we are doing, we are just loading the data, loading the training and testing data, and one major thing is that we are saving the training and testing data in the transformation notebook as Parquet uh, because we are transforming and creating vector assembler, basically about getting features, and to preserve the features we are storing it as Parquet, and after Parquet we are loading the data in this training and testing for the training and testing. This is actually a magic command which is used to access sensitive variables such as access key, mount point, etc. So we are loading this file. We're checking if there's a mount point. If it exists, it won't create. But if does not exist, it will create. We are getting the train and test data, and here we are importing the machine learning models. We are running a bunch of classification models and seeing how it performs. So here getting the number of features. how many features are there, because this will be important for the multi-layer perceptron as an input layer. The first layer is input layer, so we need to have the number of features. Then it's just a model declaration. Here we are declaring the models, what are the feature columns and label columns for all the models. Then we are basically training the models on the training data, and it goes till here, and we are making prediction on test data by basically transforming it, so it gives a prediction column. So after doing this, we are doing an evaluation of the metrics. So we are doing AUC curve here, how much it is. So you can see the AUC values of each and every model. It's the highest one if AUC is 0.91 for GBT, and looking for precision recall curve for each and every model. You can see again GPT performs well. Then we are looking at the accuracy, and accuracy is good for GPT. Confusion like we are doing confusion matrices. You to see the true positive, false positive, true negative, false negative rates for each and every model. So we are doing this for, and this is done in a distributed way because we are doing converting it into RDD, and uh, zipping it into prediction and actual values. So that's how it's done, confusion matrix. And then what we are coming, we are actually saving these models back to ADLS Gen 2 just in case if anybody wants to reuse them in the later, they don't have to train it again. They can directly run that predict on the test data. So we are saving the models in ADLS, and here we are generating a report on each of the models. What are the metrics, AUC, ROC, PR, everything. So we are saving the report back into ADLS. Now, if you see, we have completed this transformation. If you go to ADLS, this is a container storage. We have all the data. We have raw data here. Then we have the transform data. The transform data is balanced train.csv. These are like two parts. We are fetching these two in the machine learning, and this is the test data. We are fetching this in the machine learning model, and then we have uh, the reports. We are saving the models here. You can see all the models are here saved. You can use it next time instead of just training it. And we have reports here, which is very essential, because if you want to see the report of all the all the machine learning models, you can see here. So which one performed well, accuracy, precision, recall. So if you see, for this case, recall is the best because we need to get as many churn customers as possible. So if you see recall, these two, GBT and gradient boost and multi-layer perceptron are doing a really good job. But if you see the F1 score for GBT, it's really good gradient boost. Uh, so the best model is this one, and this was our project. So some of the challenges we faced during this project was to understand to our main aim was to not only just solve a problem but create a pipeline that would segregate a different transformation and transfer different operations into individual components. We had to learn Azure Data Factory and ADLS. Other than that, for data visualization, we came up with two ideas. First was to use Handy Frame, because Handy Frame was really helpful for visualization. Because otherwise, if you search on the internet, it's usually like saying convert to pandas and then plot it, which is not a good not good thing for large data sets. So we had to convert it into data frame, sorry, Handy Frame, and then we went with another approach, which was converting data to RDD. So calculate all the uh, rows, like convert all the rows into RDDs and calculate all the mean, mode, skewness, everything in the worker nodes, and then bring it to the driver node to display them. That's another approach. So in transformation, what we faced was like for the Smote, there's no inbuilt library for Smote. There's no support for Smote in uh, Spark. So we had to write our code ourselves, basically like using knn to find the so filtering only the positive values, finding the k nearest neighbors, and adding some random sampling to it to get the artificially generated or minority oversampling technique. So we had to implement it all by ourselves. For transformation, the code is here. And yeah, these are the challenges we faced, and that is all we have for this project. Thank you.
Thank you.